Just a quick reminder, the definitions from the examination guideline, please revise them every day. Make sure you memorize them, you're able to recite them in a test. Another quick reminder on the 3 scenarios in the conservation of linear momentum questions. The definition, the total linear momentum of an isolated system remains the same. Total momentum before equals to total momentum after. So you write this before you, when there are 2 objects involved, you write that, or you can write it as sum of the momentum before equals to sum of the momentum after. When 2 objects are separate before collision, they collide, they remain separate. We have the momentum like this: momentum of object 1 before plus momentum of object 2 before collision equals to momentum of object number 1 after collision plus momentum of object number 2 after collision. So this links with this the 2 objects. So when they separate before collision, they collide, and then after collision they stick together. We have momentum of object 1, so it's momentum of 1 before plus momentum of 2 before collision equals to momentum of the total momentum after collision. Now they are combined. This is the momentum of 1 plus 2 after collision. And when they are separate, they are combined. Scenario number 3, when they are combined before collision, they collide, they somehow an explosion happens. So when you have 2 objects stuck together before an explosion, it explodes, then they are separated into 2. We have total momentum before with the same velocity equals to total momentum equals to momentum of object 1 after collision plus momentum of object 2 after collision. Now let's see it in the questions how is asked. Here we have 2 lap trolleys P and Q. Let's hope it's visible. Let's check. Okay, it's not visible enough. Let's zoom it in. So we have 2 lap trolleys P and Q with masses 2 kg and 1 kg respectively. They move towards each other in the same straight line on a horizontal surface as shown in the diagram. The trolleys collide head-on and proceed to move as a unit. So they proceed to move as a unit. So it means after collision they are combined. So we have a scenario, a situation where we have 1 plus 2. They combine after collision. So let's firstly write everything given to us. So we have P. So before collision, before collision, we have mass 1, mass of object 1 is 2 kilograms, and that one of object 2, mass of object number 2 is 1 kilogram. 1 kilogram. This one is moving with a velocity of 5 meters per second. So this is P and this is Q. 5 meters per second to the right. And this one is moving with initial velocity of 2 meters per second to the left. After collision they stick together. So after, we have now mass 1 plus mass number 2 combined, and this gives you 2 plus 1, which is 3 kilograms. After collision they are combined. Then they have one final velocity, and this velocity is not given to us. So the step number 1 says, a question says, calculate the velocity with which they move after collision. So remember the scenarios given to us. This will be scenario number 2 in our case, because they were separated before collision, they collide, and then they stick together. So it means we have to write our formula like this. So let's see how we solve it step by step. So we first write the sum of momentum before equals to the sum of momentum after. People, this is not a P. it's not an E. It's the Greek letter which denotes the sum of several things. So the sum of momentum before collision, they're separate, so it will be momentum of 1 plus momentum of 2 equals to total momentum of 1 plus 2 final. So this is mass 1 velocity 1 initial plus mass 2 velocity 2 initial equals to mass 1 plus mass number 2 and final velocity. So let's substitute. Before we substitute, let us choose the direction that we take as positive. Let's take to the right as positive. So to the right is positive. You don't need to show this part. You don't need to show it. You can move directly from this part to this part. So you can move directly into that step. So substituting for 1, let's take 1 will be P and then 2 is Q. So 2 kilograms and initial velocity we're taking right to the right as positive. So this is positive 5 plus the 1 kilogram block is 1 kilogram. The initial velocity is negative 2 because it's now to the left. It is moving at the speed of minus 2 meters per second. This is equals to the masses combined is here. Remember, I said parallel, so it's 3 kilograms and final velocity. This is the only thing that we do not have. Now we solve the equation. This is 10 minus 2. We have 8 kilograms meters per second equals to 3 V final. And then in this step, you divide by 3 both sides. You get V final velocity. When you divide by 3 will cancel 3. Then 3 goes 2 point something 0.67 into 8. So this will be the final answer will be equals to 2.66666. So we round off to 2 decimal places, 0.67 meters per second. Our answer came off as positive. So we remember that we chose to the right as positive. So it means the direction of our velocity is right. Remember to write the direction for all the vector quantities. When whatever you're calculating is a vector quantity, write the direction, please. So we are done with question number 1. This one. We are done with it. We've answered the question. So in a test, this is how you'll be marked. 1 mark for formula. Okay, any between the two, anyone that is written correctly will be awarded a mark. So 1 mark, let's say 1 mark here. Then you get a mark for everything on the left if it's written correctly together with the correct directions. Then everything on the right is another mark. Then you answer with units and the direction is a mark. Sometimes the answer and units is a mark alone and then the direction is a mark alone. But in this case, let's just give it all of it 1 mark. You get 4 marks. Let's have example number 2 of a different scenario. Example 2. We have 2 balls with mass and velocity as indicated in the diagram. They collide head on. After the collision, the 2 kilogram ball bounces back with a velocity of 2.5 meters per second. So it bounces back, so it means it goes into the opposite direction. So the 2 kilogram block, this one was going to the right. So it means after collision, it will be going to the left after collision. So let's write down everything. Let's write down the data now. Let's write down everything we have. They say before collision we have body 1 and body number 2. So body 1 is the ball with the mass of, let's take this one as 1. This one will be our 2. So it has a mass of 2 kilograms This one has a mass of 5 kilograms. Initial velocity of ball number 1 is 3 meters per second to the right. Please write this as you are collecting your data. Then initial velocity of ball number 2 is 3 meters per second to the left. After collision, the 2 kilogram ball bounces back with a velocity of 2.5 meters per second. So after the mass still is the same, the final velocity for this one is going to be 2.5 meters per second now to the left. It was to the right, so it bounces back to the left. So notice that we do not have final velocity for this one. They say name 2.1 in answering the question. Name the law that applies to this event. So 2.1, the law that applies to this event. Notice carefully. When they collide and bounces back, this is the law of the principle of conservation of linear momentum. So conservation of linear momentum. But remember, during collision, when they are touching each other, the moment when they are still they are touching each other, Newton's third law apply, because they apply a force, they exert a force on each other, a repulsive force. Not repulsive force. They exert contact force on each other. Ball number 1 will be pushing ball number 2 to the other direction. Ball number 2 will be pushing ball number 1 in the opposite direction. Let's go to question number 2. Calculate the velocity of the 5 kilogram ball after collision. So 2.2, we have to calculate the velocity of the second ball. We need to calculate this velocity. So we start by writing the principle of conservation of linear momentum. Total momentum before equals to total momentum after. And we remember this scenario. Before collision, they were separate. They hit each other and then they go into opposite direction. They still remain separate. So it means it will be momentum of ball number 1 initial plus momentum of ball number 2, or momentum of ball number 2. This is V2, M2 V2 I equals to momentum of ball number 1 after plus momentum of ball number 2 after. Okay, excuse me. So we have this scenario. Now let's substitute everything that we know about this problem. So the mass of ball number 1 is 2 kilogram. Wait, before we continue substitution, we need to choose direction. We did not choose direction. Let's take to the right as positive again. So we have anything moving to the right is positive. Any velocity to the right. Remember, the mass does not have direction, it's a scalar quantity. Only the velocity has a direction. We will never include negative or positive values, negatives for mass, negative for velocities only. So initial velocity of ball number 1 will be 3 meters per second, correct as positive because it's to the right. So this plus mass number 2 is 5 kilograms, and it was moving to the left, so it's minus 3 because this is to the left. Equals to momentum of ball number 1 final is going to be 2 times, now the velocity final of object number 1 is to the left, so it's negative 2.5 plus 5, and final velocity we don't know, we leave it as VF. Do not choose the direction for an unknown because you don't know where is it going or where will it be going. You cannot assume that it will be moving to the right. Even if you are sure that it will be moving to the right, you don't choose direction. So we have this now, and then we just do the math. 6 minus 15, we have 9, so it's 9, negative 9, and minus 5 plus 5 V final. Now the next step is to transpose 5 to the other side. Let me just confirm. Yes. We transpose 5 to the other side, it becomes positive, so we have, now we will have minus 9 plus 4, minus 9 plus 5, so that is minus 4. Minus 4 equals to 5 final velocity. Then we divide by v final, both sides, divide by, I mean not by 5, divide by 5 both sides. Then you have 5 will cancel 5, and then 5 goes how many times into 4? 0.8. So v final equals to negative 0.8 meters per second, because it's velocity. You don't write direction, still negative, ne? Rewrite it as positive. Final velocity is equals to 0.8 meters per second. Remember, it's negative, so it means it is not going this direction, it's going left. There you have it. And you get marks for writing the correct formula. The left hand side substitution is correct, all of it. The right hand side substitution is correct. And your answer with the units and the direction is also correct. Get 4 marks. It's mostly 4 marks in most tests. Yep, I think that brings us to the end of this question. Let me check if there's still more. This brings us to the end of this question that we're solving. Yes, there's still more. There's 2 more questions on the same, it's a continuation of this, so it continues to 2.3 and 2.4. So 2.3 says calculate the change in momentum that the 5 kilogram ball undergoes. The change in momentum for the 2 objects, let me just clarify that. Change in momentum for object 1 equals to minus change in momentum for object 2. So the change in momentum is the same, just different. It differs with size. Due to Newton's second law of, in Newton's second law in terms of momentum, we have this. So they are the same size, they are the same magnitude, they have the same magnitude but different in size. So let's calculate change in momentum that a 5 kilogram blocks undergoes. So it's change, nope, let's use different color. Change in momentum equals to the mass final velocity minus initial velocity. This is the 5 kilogram block, 5, and the final velocity of the 5 kilogram block. Remember that the final velocity of the 5 kilogram block is what we're calculating. It's the value that we do not have here. It's what we're calculating, and we found it to be 0.8 meters per second. So let's summarize it here. So it's change in momentum equals to m final velocity minus initial velocity, and this is 5 final. Let's continue taking to the right as positive. So final is in the negative direction, it's going left, so it's negative 0.8 minus the negative, there's minus sign from the formula. Then the initial velocity was to the left also, so it should be minus into minus 3, and you put this in a calculator to get your answer. So you have 5 into negative 0.8 minus into minus 3. You have 11. So 11 kilograms meters per second. 11 kilograms meters per second. I hope we did not do anything wrong. Now let's just confirm this. I said to you that the change in momentum is the same. It differs the sign only. So let's see. For instance, just to check, the change in momentum for the other block will be the mass. The other block is 2 kilograms, ne? So it's 2. Its final momentum was 2.5 to the left, so it's negative 2.5 minus 3, because 3 it was to the right, so we have 2 into minus 2.5 minus 3, and this you get negative 11 kilograms meters per second. You get negative 11 kilograms meters per second. So you can see the two values are equal, they just differ in the directions. This one is to the right, this one is to the left. All right, we are done with 2.3. Now let's check 2.4. 2.4, it says if the time of contact between the balls is 0.5 seconds, calculate the force that the 5 kilogram ball exert on the 2 kilogram ball. Yeah, here let's remember again the free ball diagrams. We have the smaller ball, then we have the other one. The 2 kilogram ball is pushing the 5 to that direction, so this is a force of 2 on 5, right? But Newton's third law says that at the same time this one will be pushing the smaller ball to the right, to the left, so this will be the force of 5 on 2. The forces are equal but in opposite direction. But here the question says that calculate the force that the 5 kilogram ball exert on the 2 kilogram ball. The force that 5 kilogram exert on the 2 kilogram ball is this one, is to the left. And if you keep the same direction as it was in the other questions, we took to the right as positive. Let's keep it the same and solve this question. So we will have the force that 5 exert on 2 equals to change in momentum divided by change in time. These are the only two forces acting on these two objects. So it's they are equal. We're calculating this one. So it's to the left. So it means the change in momentum for this one will be negative 11, because negative is to the left. Minus 11 divided by 0.5. Or you can just take it as, ignore the issue of sign and take it as 11 divided by 0.5. But remember that the direction of this force is to the left. If you take it like that, if you put negative, yes, you can put negative and then you'll change it again. But now you get this will be 11 divided by 0.5 is 22 newtons. And the direction is left. Force is a vector quantity, so with a direction. You get 3 marks for this formula, 4 marks sometimes, substitution, and the answer. Okay, it's 3 marks because already we calculated this value in the previous question. But sometimes it's 4 marks. You get a mark for calculating the change in momentum on top, and then the substituting the value for change in time. There we have it as 3 marks. This is the last question for this. Oh, we did not mark the previous one. The previous one will be marked 3 marks as well. Mark for formula, substitution, and the answer. This brings us to the end of this part. We can in the next video, what I'll be doing is I want us to discuss these different scenarios from different past papers. We'll solve firstly this one. Let's zoom out a bit. Firstly this one, then you move on to solve other 2 papers. See you in the next one. Please subscribe to my YouTube videos and like my videos. Thank you.